Have you ever stood on the ground and wondered what's directly beneath your feet? Not just a few feet of soil, but miles and miles down, all the way to the very center of our planet? Imagine for a moment that we could embark on the ultimate adventure, an impossible voyage to the Earth's core. What would we see? What strange new worlds would unfold before our eyes? It's a journey that has captivated scientists and storytellers for centuries, a dive into an unknown realm that's more alien than the surface of Mars. Today, we're making that impossible journey a reality, at least in our minds. We're going to explore what it would be like to travel nearly 4,000 miles straight down, through layers of rock, molten metal, and unimaginable pressures. This isn't just science fiction, it's a deep dive into the very science that governs our world. From the ground beneath our feet to the fiery heart of our planet, we'll uncover the secrets hidden deep within the Earth. But before we start our descent, let's get our facts straight. Pop culture has given us some wild ideas about the Earth's interior. You might picture vast, open caverns, prehistoric creatures, or maybe even a whole other civilization thriving down there. While those make for fantastic stories, the reality is far more extreme, and in many ways, even more mind-bending. Our journey will be guided by real scientific data, information gathered from studying seismic waves, analyzing volcanic rock, and complex computer modeling. These are the tools that allow geologists to see into the planet's depths without ever drilling more than a few miles. So, let's start by understanding the map for our journey. The Earth isn't just a solid ball of rock. It's structured in distinct layers, almost like a giant planetary onion. The first layer we need to breach is the one we live on, the crust. There are two types: the continental crust, which makes up the land masses and can be up to 40 miles thick in places like mountain ranges, and the oceanic crust, which is much thinner, usually only about 3 to 6 miles thick. For our hypothetical journey, let's say we start our drilling operation in the middle of the ocean, where the crust is thinnest. It's our best shot at getting a head start. Even getting through this first thin layer is a monumental challenge. The deepest hole ever drilled by humans, the Kola super deep borehole in Russia, only made it about 7.5 miles down, and that took 20 years. The temperature at that depth was already a scorching 356 degrees Fahrenheit, far hotter than expected, and the rock started behaving more like a plastic than a solid, making drilling almost impossible. Our mission will require technology far beyond anything we have today. Imagine a vessel built from a material that can withstand both immense pressure and blistering heat. As we break through the crust, we enter the next major layer, the mantle. The mantle is the real behemoth of Earth's interior, making up about 84% of our planet's volume. It's a layer of silicate rock that extends down for about 1/800 miles. But don't picture a simple, static layer of rock. The mantle is in constant slow-motion movement. It churns and flows over millions of years in a process called convection. Hotter, less dense rock from deep within the mantle slowly rises, cools near the surface, and then sinks back down. This is the engine that drives plate tectonics, moving continents, creating mountains, and causing earthquakes. Our vessel would feel the effects immediately. The pressure here is crushing, thousands of times greater than at sea level. The temperature is also climbing dramatically. At the top of the mantle, it's already around 1,600 degrees Fahrenheit, but as we descend deeper, it will rise to over 7,000 degrees. The rock here isn't a liquid, but it's not exactly solid either. It's a strange semi-solid state called a rheid, which flows like an incredibly thick fluid over geological timescales. For our vessel, it would feel like pushing through super-hot, ultra-dense putty. As we descend through this vast, glowing, and slowly churning sea of rock, we'd be traveling through different zones of the mantle. The upper mantle, which includes a rigid part called the lithosphere along with the crust, and a weaker, more fluid part called the asthenosphere. This is where the tectonic plates float. Deeper still, we'd enter the lower mantle, where the immense pressure forces the minerals in the rock to change their crystal structure, becoming denser and more compact. We wouldn't see caverns or monsters, but a mesmerizing, shifting world of incandescent rock, compressed into exotic mineral forms that can't exist on the surface. After a journey of 1,800 miles through the mantle, taking who knows how long, we would finally approach the next great boundary, the core mantle boundary. This is a transition zone more dramatic and mysterious than the surface of the Earth itself. Here we leave the world of rock behind and enter a realm of metal. The pressure is now a staggering 1.3 million times atmospheric pressure, and the temperature is hotter than the surface of the sun. Our vessel would need to be made of some truly miraculous, theoretical material to survive this transition. Suddenly, we break through. We are now in the outer core. And for the first time on our journey, we are in a true liquid. But this isn't water. It's a swirling, turbulent ocean of molten iron and nickel, stretching for about 1,400 miles. The temperature here hovers around 8,000 to 11,000 degrees Fahrenheit. The flow of this liquid metal is what generates Earth's magnetic field. This field is our planet's shield, protecting us from harmful solar radiation and making life on the surface possible. As our vessel navigates this molten sea, it would be tossed around by massive, powerful currents like a tiny submarine in a planetary-sized whirlpool of liquid metal. The sheer energy and power of this place would be awe-inspiring. Imagine looking out the viewport of our vessel. There would be no light other than the intense white-hot glow of the molten iron itself. We would be witnessing the very heart of our planet's dynamism, the engine room that has shaped our world's destiny for billions of years. Navigating this inferno would be the ultimate challenge. The convection currents here are far more vigorous than in the mantle, driven by the intense heat radiating from the very center of the Earth. And that brings us to our final destination. After traversing the chaotic liquid outer core, we arrive at the final frontier, the inner core. At about 3,200 miles below the surface, we reach a boundary where something incredible happens. Despite the temperature being even hotter, estimated at around 10,800 degrees Fahrenheit, as hot as the sun's surface, the pressure is so immense, over 3.6 million times that of the surface, that it forces the iron-nickel alloy back into a solid state. We have arrived at the Earth's inner core, a solid ball of metal, about 760 miles in radius, slightly smaller than the moon. It's a sphere of iron and nickel, glowing at an unbelievable temperature, yet squeezed into solid form by the weight of the entire planet pressing down on it. Recent studies even suggest the inner core might be more complex than we thought, possibly having its own inner core with different properties. Scientists also believe the inner core is slowly spinning, perhaps slightly faster than the rest of the planet, though this is still a topic of active research. Here we are, at the very center of the Earth. There's no more down to go. We are floating at the heart of our world, a place of paradoxes, solid yet hotter than lava, a place of immense stillness under unimaginable pressure. The journey was impossible. The conditions were beyond extreme, but the theoretical voyage reveals just how complex and dynamic our planet truly is. Every layer we passed through plays a crucial role in making Earth the living, breathing world we know. From the churning mantle that moves continents to the liquid outer core that generates our protective magnetic shield, the inner workings of our planet are a beautifully intricate system. Our imaginary voyage to the center of the Earth might be pure science fiction for now, but the science it's based on is very real. It's a testament to human curiosity and our relentless drive to understand the world around us and within us. Every earthquake that rumbles, every volcano that erupts, gives us another small clue about the incredible world hidden beneath our feet. And who knows? Maybe one day, centuries from now, this impossible journey won't be so impossible after all. Thanks so much for joining me on this incredible theoretical adventure. It really makes you think about the ground you're standing on in a whole new way, doesn't it? If you enjoyed this deep dive, please hit that like button and be sure to subscribe and turn on notifications so you do not miss our next exploration into the wonders of our universe. Let me know in the comments what other impossible journeys you'd like to see us take. Thanks for watching.